Okay, now let's do an example here. Okay, given that distributed loading on the bookshelf as shown, so you have a distributed load system like this. Okay, so find the magnitude of equivalent resultant locations, which means that equivalent resultant force of the distributed load, and the question asks you to find the location of the resultant force here. Okay, the F resultant here. So the question asks you to find the location of resultant force from point O. Okay, from the point O here, where the location of the FR, or what is the distance of X from the point O here. Maybe the force resultant is here or here. Okay, so we don't know, so we need to calculate. Okay, so the step to do this question is the first one is you need to find the force resultant FR1 and FR2, force resultant for this distributed load and this distributed load. So there is two distributed load system here, and find the X bar centroid for each of these two distributed loads. So please remember that for distributed load, the F resultant will act at the centroid of the of all the distributed load. Okay, or the distance of the distributed load. Let's say if X here is equal to 4, so the F resultant will act at the center of the along this X. So which means that it will act at the distance of 2. Okay, so at the center, so this 2 and this one is 2. Okay, so you need to find the x2 in this case, sorry, x1 and x2. Okay, so for this one and for this one. Okay, so and then after you get the F resultant 1 and resultant 2, so you will simply add those resultant force to get the total resultant force of the whole system. Okay, and then the step 3 is to find the moment resultant of the whole system, the moment resultant, and find and using the equation of moment resultant is equal to X bar multiplied with F resultant, so find the X bar. Okay, this X bar is for the total moment resultant and the total force resultant. So where is the location of X bar? Okay. Okay, let's redraw the diagram there. So you have a platform like this. Okay, so your books produce a distributed load. So there are two distributed load system. So the first one, let's take red color. First one is like this. Okay, and then the function of the distributed load is given as W1, which is equals to 30 Newton meter. Okay, please remember that the function of W1 or intensity of force is equals the unit is Newton over meter. Okay, so the second one of the distributed load system, you have the shape is like this. Okay, with the function of W is equals to 50 newtons meter. And then given that there is a center point here, which is at which is at a point O here. Okay, so and then it is also given the distance from here to here, somewhere here, distance SA is equals to 1 meter. Okay, then from here to here, between the system, the first system and the second system, the distance of B is equals to 1.5 meter. And then from here to here, SC is equals to 0.5 meter. Okay. Okay, from here you need to find, let's say for the first one, you need to find the force resultant of this distributed load. Okay, and then force resultant is normally acting at the center of along the distance of this distributed load. So let's say here, so this is FR1. Okay, must so if it is at the center, so what is the location? So from here to here, center, what is the location? So you need to so from here to here is B, right? So B divide with 2, so you can get the center. Okay, so you divide 2, so you will get the center of the distance x here. So that's where the FR1 is act on. Okay, same goes to this one. Okay, so the center here is, you take C, divide by 2, so you will get the distance here. Okay, that is where the F resultant 2 is act. Okay, in the center of the distance along the distributed load here. Okay, now how to find the FR1. Okay, so FR1 is simply you multiply the function here with distance of x. So if you take here, okay, so your W1 is equals to 30 Newton per meter, and then multiply with distance along the distributed load is, you take this distance, which is B, is equals to 1.5, so multiply with 1.5 meter. So eliminate this, you will get the unit of Newton, or the force here, the FR1 here, which is equals to 45 newtons. Okay, that is for FR1. Same goes to FR2. If you take out this thing here, okay, this is FR2. So FR2 is equals to the function of W, which is 15 Newton meter, multiply with the distance of x along the distributed load here. So in this case is C 0.5, so multiply with 0.5 meter. Eliminate this, you will get 25 Newton. Okay. So the total resultant force here, Fr here, is simply a sum of Fr1 and Fr2, which is equal to, okay, let's change the color here. Fr is equals to Fr1 plus Fr2. Okay, this is equals to 45 plus 25. Is equals to 70 Newton. Okay. So your total F resultant is equal to 70 Newton. The whole distributed load, the total resultant force is equal to 70 Newton. Okay, now you have a system like this, so you already get the force resultant for this distributed load and this distributed load. Okay, now the question asks you to find the moment resultants of the whole system about point O here. Okay, so which means that about point O, the whole system has a tendency to rotate. Okay, so if the pin is here, so your rotation will be one rotation is over here and another one is here. Okay, so it goes like this. Okay, because the moment is about point O. Okay. Okay, so to get a moment, you need to multiply a line of action with the force. So in this case, from O, line of action for Fr1, let's say D1 here, and then from O to line of action for Fr2 is D2 here. So M resultant about point O is equal to D1 multiplied with Fr1 plus D2 multiplied with Fr2. Okay, so how to find the D1 and D2? Okay, okay, it is given that from here to here to here is given the distance of A. Okay, and then one more is from here to the Fr here is a B, is a half of B. Okay, because Fr1 is at the center of the distributed load here. Okay, along the distributed load here. So Fr1 here is at the center, so along here is B, so the center is B over half of B lah. Okay, so to get D1 here, this means that you need to, because this is an A, so to get the portion here, which is D1 here, so you need to subtract A with the B2 here. Okay, so you will get this portion. So which means that D1 is equals to A minus B over 2. Okay, multiply with Fr1, then plus. So how about D2? So I have to find D2 from the point O here. Okay, D2, so you have from here to here is B, right? I mean to here, to point here, okay? So from point here to point where the FR2 is located, previously we take a half of C, okay? Because the whole here is C, so because it is act and on the center of the distributed load, so it is a half of C. FR2 is act on the half of C, okay? So to get from point O, get this portion here, okay? So how will you find it? So which means that if this is B, so you need um, to eliminate this portion, which is A, eliminate this distance. So which means that B minus A, okay? So you will get this portion, and then add with the half of C here, so you will get the distance from O here to FR2 here, okay? So plus half of C, okay? So D2 here is equals to this one, okay? B minus A plus C over 2, okay? Multiply with FR2, okay? So substitutes all the value here, okay? And then here, this you already get this one also. So your moment MR naught you will get should be equals to negative 11.25 plus 18.75 Newton meter. Okay, why this moment is negative, or simply we can denote this as moment 1 and moment 2. So why the moment 1 is negative? Because if let's say the system is like this, okay? So moment about point O, so this is your FR1, this is your FR2. Okay. Let's set the clockwise is positive, okay? So this means that when the moment is about point O, so this is your line of action, this is your force, so the rotation will be going that way, okay? So one more force is going this way, so this way is clockwise, so follow the one we set here. So this one is positive, so this one is positive, and this one is reverse, so this one is negative, so this one is negative, okay? You can also set this one is in the other way around, okay? Anti-clockwise is positive, so the answer will be will give the same answer. So for this one it will give the answer is positive, okay? So if you set the rotation positive is anti-clockwise, you will get the answer is negative. That means that it's supposed to be the rotation is supposed to be the other way around, okay? So if the answer is positive, so your assumption is correct lah. The clockwise is positive. Okay, so after you get the MR node, so the question actually asks you to find the location of where the total resultant force is at, okay, about point O. So you need to find the from point O to FR1, which is X bar. Okay, using the equation of MR naught equals to X bar multiplied with F resultant, so simply you will get X bar is equal to MR naught divided with FR. So this one, MR naught, right? 11.25 plus negative 18.75 Newton meter. Divide with your FR, which just now you calculate, you get at 70 Newton. So eliminate this, so you will get the answer is equals to 0.107 meter. Because this is positive, so the direction from point O is on the right direction. Okay. Remember that from the 0 to right direction is positive, to the left is negative. So this means that the X bar is on the positive direction. So the F resultant here is X on the right direction from the point O here. So somewhere here lah, FR. The distance from point O is 0.107 meter. Okay. Or simply we can write like this: from point O, this is your FR, and then this is your distance, 0.107 meter. Okay, that's it.